This video is a 3D Sketch overview. 3D Sketch is only available in the Part workspace and allows you to create guide curves to control lofts and allows you to create sweeps that are ideal for modeling piping and cabling systems. To enter 3D Sketch mode, under the Part Modeling tab on the ribbon, click on the small down arrow in the Sketch group and click on Activate 3D Sketch. 3D Sketch has its own toolbar, set of sketch constraints, and its own set of tools, including spline, define coordinate system, cycle sketch plane, elevate, and elevation. Generally speaking, 3D sketching should be used with a grid active so it will give you a reference as to where you are sketching. It's important to understand that with 3D sketching, you do not need to sketch on a planar face or plane. However, if you're not sketching on a plane, your sketch could end up out in space. Here's a 3D sketching sweep example. The sweep profile must be a closed 2D sketch. We'll create a couple of circles centered on the origin. Whenever possible, use the origin point for the item to be swept, as well as the beginning of the path, to keep things simple. When you sweep a 2D sketch, every single item in that sketch is swept. These two circles swept together will create a tube. The path can be either a 2D or 3D sketch. In this case, we'll use a 3D sketch, so 3D sketch mode is initialized. If the path is not started at the origin where the profile is centered, the sweep will be offset. A short vertical line will be started from the origin point. The current active plane is XY. We're going to activate the YZ plane so we can easily create a line that is perpendicular to the plane of the circles. There are at least 4 different ways to cycle through the 3 major planes. 1. The Cycle Sketch Plane icon in the Sketch Tools group on the ribbon. 2. Right-click the mouse and select Cycle Sketch Plane on the pop-up menu. 3. Press and release the Tab key on your keyboard. Or 4. Press and release the letter F on your keyboard. After creating a horizontal segment from the end of the vertical line, the F key is pressed once to cycle the ZX plane where a couple more segments are created. Here's a tip. To change the elevation on the current plane, hold down the letter E while moving the mouse cursor. You can start drawing a line at one elevation, and then press E while placing the other end of the line to achieve a diagonal line between the 2 different elevations. You will notice a yellow line between the mouse cursor and the intersection of the 2 green lines. This yellow line represents the vertical distance between the mouse cursor and the current active plane. When you release the E key, this vertical distance will remain fixed until you change it. The intersection of the 2 green lines represents the position on the plane directly below the mouse cursor. The fillet command comes in handy for rounding those sharp corners, no matter which plane the lines are oriented to. Now to sweep the profile. Sweep Boss is selected from the Boss group under the Part Modeling tab on the ribbon. When the dialog box appears, the profile to be swept is entered by selecting it in the Design Explorer, and then the path is entered by selecting it as well. When the OK button is clicked, the swept part appears. And now for 3D sketching Loft example. A loft is composed of 2 or more 2D closed sketches, each on its own plane. A 3D spline is selected from the 3D Sketch toolbar and attached to a point on each of the 2D sketches. Coincident constraints can be utilized to ensure contact with each profile sketch, but this was not required in this example because we're using endpoint nodes to attach the path to. Once the guide curve is in place, the Loft Boss is selected from the toolbar. In the dialog box, each of the profile sketches is input in the cross-sections box by selecting each one in sequence. It is very important to select these cross-sections in sequence. You can't choose the one in the middle first and then the 2 outer ones, for example. It needs to be either 1, 2, 3 or 3, 2, 1, but they do need to be in sequence. Now the guide curve is selected and the OK button is clicked. The guide curve must intersect each of the 2D profile sketches. The guide curve cannot simply intersect a sketching plane, because guide curves represent edges of a part. If the guide curve does not intersect each of the profile sketches, you will receive an error message. When sketching in 3D, sketch constraints are often needed to help control the geometry of the sketch figures. The sketch constraints shown here can be used as normal sketching constraints and are similar to 2D sketching. There are only two new sketch constraints. These are the tangent continuous and direction constraints. Tangent continuous. This will make an arc and a line tangent to one another and make the end nodes of the figures coincident to each other. Direction. This will constrain a line, so if it is moved, it will always remain oriented in the same direction it is currently facing. In this 3D sketch overview, you have been introduced to 3D sketching. You have also gained an understanding of the processes involved in creating 3D sweeps and lofts using Alibre design.